Let's work on this problem of series. This is an example of telescoping series. Here, our general term is this. Let's write it down on the side. 2 by n square plus 8n plus 15. My first step is I'm factoring the denominator. It's a quadratic. I need two numbers whose product is 15 and sum is 8. So that should be n plus 3 and n plus 5. Now, what I want to do next is, I don't know have directly any, this is not a geometric series. I'm going to use partial fractions technique, which we learned in integral, to separate it out like this. Okay. How do you find a and b? You first make the common denominator. A times n plus 5 plus b times n plus 3. Comparing these two, the numerators have to be same. So 2 is equal to a times n plus 5 plus b times n plus 3. This has to be true for all n. So let's put n is equal to negative 5. When I put n equal to negative 5, the first term will become 0. So 2 equal to negative 5 plus 3, negative 2b. b is coming to be negative 1. When I put n is equal to negative 3, 2 is equal to negative 3 plus 5 is 2a. And that term will become 0. That means a is equal to 1. So using our expression of the general term and a and b values, we can say our given series can be written as 1 divided by n plus 3, because a is 1, minus 1 divided by n plus 5. Now you guys notice that this is S infinity, which we are trying to find, the sum up to infinity. Okay. What if we write Sn? Sn means the sum from 1 to n of these terms. Let's try to put the counter as 1. Let's do that. When I put 1 in there, this will be 1 by 4 minus 1 by 6. When I put 2 in there, this will become 2 plus 3, 5, minus 2 plus 5, 7. When I put 3 in there, this will become 1 by 6 minus 1 by 8. When I put 4 in here, it will be 1 by 7 minus 1 by 9. You keep on doing that. And then you put n in there. What will you get? N plus 3 minus 1 by n plus 5. What about the previous term of that? When I put n minus 1 in there, that would be n plus 2 minus 1 by n minus 1 plus 5. So that will be n plus 4. Now I've expanded this whole unto nth terms. You guys notice this 1 by 6 and this 1 by 6 cancels because they are equal and opposite. This 1 by 7 cancel. So there is a pattern here. Somewhere 1 by 8 is going to cancel with the next term, right? And so on. All the terms, 1 by this is going to be cancelled with some previous term. This is going to be cancelled with some previous term. What we are left with is 1 by 4, 1 by 5, this and this, 4 terms. So Sn is equal to 1 by 4 plus 1 by 5 minus 1 by n plus 4 minus n plus 5. But we want to find S infinity. S infinity would be limit n approaches to infinity of Sn. Basically, limit n approaches to infinity of this expression which we found. N plus 5. Now, sorry, this is 5. You guys notice the first two are just constants, but when n approaches to infinity, n plus 4 also approach to infinity. So this approach is to 1 by infinity basically, and 1 by infinity is 0, and this will approach to 1 by infinity, which is 0. So you guys remember from limits, limit x approaches to infinity 1 by x is 0. That is what I'm using, that these both limits approach to 0. So my final answer should be 1 by 4 plus 1 by 5, 29 over 20. Okay, so what we are concluding is our given series converges to 9 by 20.